I'm going to take a topic that's kind of a taboo because people, well, they don't fully understand what we're happening in this thing about removing an inlet barrier when it rains. And I've had everything from, well, we don't remove anything to, whoops, you got a little bit of water in the gutter, we better remove all those barriers. I hope I give you a little bit of some of the things that we have to deal with. First of all, this is the requirement in Hawaii right now, where on HAR 55, it says inlet measures can be removed in the event of flood conditions when safety or loss of property is of concern or to prevent erosion. Nice. How does that compare to EPA's 2017 construction general permit, for which Hawaii is going to be going to, because the old one expires December 6th of this year. And if you look at it, there's a little footnote there. You see something that says, hey, basically almost the same thing. There's a little bit of difference where safety is not in there. EPA doesn't care about safety. But that's fine and dandy. Question, what do you use to trigger the removal of the barrier? And that's the thing that's kind of interesting, because it varies wherever you are in the United States. Hawaii is definitely different than it is in Colorado. So let's take a look at a little. This is a plan that's out of Honolulu. Actually, I'm just taking one little part of it, and that's this little section that says there's going to be a inlet in front of a storm sewer. If you go to the typical detail sheets, you see something like this. They call this erosion control. There's not a single erosion control practice on there, by the way. That is all sediment control. But you blow it up over here, this little part, and we get this nice little picture. And I find that this appears, quite a few places. The catch basin inlet protection. And there's a little part in there, let me just read it to you. Contractor to remove sediment control filter in the event of an above average rainfall and replace the filter after the storm has passed. Gosh, that's cool. That's great stuff. What is an average rainfall? Has anybody asked in that room here what we mean by that? Who determines whether or not you're going to have an event that's going to exceed that? And the big question, who's responsible? Maybe we ought to say who's liably responsible. And let's just take a look at this. So we have in this particular case the statement that we're living with. And I don't know why he has the big one here. But what is an average rainfall event? Half inch? 1 inch? 5 inches? Well, let's take a look. Should we choose monthly values? There's our monthly average in Hawaii, in Honolulu. And yeah, December's going to rain a heck of a lot more than June or July is going to happen, isn't it? So should we have a criteria that's the same for all the months? Or should we vary it month by month? And that's a good question. Or do we say that the average of all months, just use that number and say that if it rains 1.43 inches, we'll remove those barriers? Only trouble is, that's a month, not a per storm event, is it? So we start saying, well, this is good, nice numbers. No, I have a lot of these. I think we better think about daily precipitation. That's a lot more important to everybody in this room. And this is a graph of daily precipitation from 1996 up to the end of 2015, beginning of 2016. They went off the graph up here, but only 4 places. You just recently had a hurricane here. This is probably where you were up in here. But don't look up here. You want to look down here at the bottom. Because the average rainfall event in Hawaii, in Honolulu, is only 0.18 inches. Wow, look at these. That's down here, 0.18 inches. Not very much for an average one. Let's see how that impacts us. If you do a pie chart on this thing, you can't read any of that in the back yet. That's fine. But 91% of the storm events are less than a half inch in Honolulu. 91%. Between a half inch and 1 inch, only about a little less than 5%. Between 1 and 1.5 inches, only about 1%. And only about 1% between 1.5 to 2. Those were shocking numbers when I saw that. Do you believe it? Yeah, I do. That's what the data is collecting here. Then we have 1.7% indeed that exceeds 2 inches. Very little of your rainfall exceeds a half inch here in Honolulu. Now, you have intense storms coming down, but do they last for long times? Or do they last for short durations? That's where it's all lying in there too. By the way, for a 2-year, 24-hour storm event, that's where the value is. Way up there at the top. There's your average for Honolulu, way down at the bottom. So, do we choose this number or that number? Well, I believe I have an answer for that one. Every contractor can say, heck no, we're not going to get close to that number. We're going to choose that one. Because that one means I can remove it for almost every storm event I ever have. Yeah, it's not a real good idea. Because you guys have something around called the Pacific Ocean and coral reefs and everything, and people are getting very concerned about those. Well, let's take a look a little bit here more. Flood conditions, that's our whole key. What is about flood conditions? It's caused by runoff, doesn't it? And how is runoff caused? By precipitation falling on land. And the more impervious the land, the higher the flood. So, let's take a look at what happens when we model this a little bit. I'm not going to give you all the model details, but say all of our soils are pure clay, or maybe it's all asphalt. That has the greatest, highest runoff potential. And let's just take a look at the potential runoff events for daily precipitation in Honolulu. The graph is a little bit different than the other one. Remember how crowded it was down at the bottom? Not there anymore. Put the pie chart on this one. Kind of interesting statistics. 79, 6.5, 4.6, and 6.5%. 79% of our storm events, of all the runoff occurs, 79% of it is going to be less than a half inch of runoff. Kind of interesting statistics here. There's your 2-year, 24-hour storm event. Remember the average? The average was at 0.184 of precipitation. The runoff is down almost at the very bottom. We do not want to use average precipitation for Honolulu. Maybe Hilo, but not for Honolulu. So, you do the comparison over here. This particular one, almost 1,800 recorded events came up with an average of 0.184 for your precipitation, average precipitation here in this city. And the runoff of the 1,794 runoff events, only 459 produced sufficient runoff to measure. Most of your precipitation events don't result in runoff here because they're very small precipitation events. Is that a shock to anybody in this room besides me? I see an awful lot of saying, I don't believe it type things, but it's true. So, you break it down onto these particular graphs. Here you got 91% of all rainfall events are less than a ½ inch. 79% of all the runoff events are less than a ½ inch. So why are we choosing something so small? That would mean that every single rainfall event in Honolulu, you should yank out those barriers in front there. Might as well get rid of the barriers, because there's got to be more criteria than that. And I'm recommending that you look at potential flood conditions by using the potential runoff events, not precipitation only. So think about these things. Take it back with you when you see these things. This is sort of a summary of all the rainfall events that we have, and the runoff that occurs. 1 inch of rainfall produces roughly a ½ inch of runoffs and so forth. That's equivalent of saying there's about 1,800 cubic feet of runoff coming off per acre of land, which is about 79. And you can go higher, by the way. Finally, you get up that 1.5 inches, that you get 90%. Now, this may be a little bit high number for your inlets, but it's a great number for your sud basins that I'm going to be talking about later on. Just to give you a comparison, there's your average rainfall event in this city. There's your runoff potential in this city. That's equivalent to 17 cubic feet per acre coming off that land. Your head showing up on there. It's nice color hair that you have, by the way. And notice that number there. 66% of your runoff events fit in this category. But that's not flood condition, ladies and gentlemen. That is, I'm just going to take advantage of the system and remove the barrier in front of the inlet as much as I can. We've got a big problem here when that occurs. So, contractor to remove, whoops, you got the feedback coming in. Contractor remove sediment control filters. It's a nice thing, but be careful with that recommendation. So with that in mind, how can we reduce the flooding at inlets? That's what you need to be thinking of. Eddie talked about that great detail today. One of the things that everybody in this room should do, contractors, designers, regulatory people, everybody, do erosion control during the construction phase, not at the end. The seed is cheap compared to the fines that can come in there. When you go onto these things, be real careful. Think about hydromulch. That's one of the best ones you have in this territory, in this area. Use it. It will save you money, not cost you money. That's the big thing that's coming out there, because the fines today with the Environmental Protection Agency, if the administrator wanted to charge you per violation, could be $51,000 per violation, in some cases per day. That's a lot of money, and it's a heck of a lot more than would be for your cost of doing erosion control out there. But let's ask ourselves, what can we do about inlet protection? Well, you got to ask yourself also, are you trying to capture trash, or are you trying to capture sediment? You'll be amazed at the difference in the two here. On the inlets and barriers, ask yourself, does the water go to a sump, or is it on a grade? Here's the grade up on top, here's the sump. Notice what's in front of the sump, notice what's not in front of the grade. Flooding. Well, in this case, when you have any barrier in front of an inlet that's on a street that's on a grade, it will divert the water downstream. It does nothing else for you. It diverts the water. It's a waste of your time and money, to be very honest with you. And I realize the regulations say put something in front of every inlet. On the sump, though, that collects water. That's your, quote, flooding. But believe it or not, that is your only technique when you're using a barrier to remove sediment, is to flood the street. There is no other way. They don't filter anything out of there. Most of the time you're on a grade, you'll get some capture of sediment here, but most of it goes in downstream and floods somebody out. So be careful putting them on a grade, because they don't necessarily work. But these do work, even though that's kind of a nasty spot to put that there, because it will do a little bit of damage if somebody ever pushed it over, and I'm sure that never happens in Hawaii. But notice in front here, look at all the sediment. If these are working, the sediment will deposit on the street. That is a good thing environmentally. It is a crummy thing when you're doing construction, isn't it? We have to try to get a compromise on it here. I'd like to take a guess in here. How much sediment exists in that beaker, assuming that's simulating a runoff? Out of curiosity, how many are going to say about 20%? I know you all have hands to raise up there, so please don't hesitate. Nobody's going to bite on that one, okay? Let's go down to 10, 15%. None of those do it? Okay. I guess all of you are saying 1 to 5%, right? Or the rest of you are saying, I don't want to raise my hand. I've had to be here because my boss told me to be here. No, we don't want to do that. Well, if you wait 96 hours, that's how much deposit comes out of that, which is right in there. Here's what we have with the situation with barriers or anything dealing with sediment control. We're not hardly controlling sediment. We have to learn how to control water and runoff. If you look at that one there, there's 90 to 95% of the volume that's in that beaker to the left is water. That's what we got to look for, is how do we get rid of the water? And how do we also trap the sediments? Here's another little clue. Anybody's inspectors in here? If you go, after a rainstorm, you go in front of a barrier, it's in front of an inlet, if it's a clean street, EPA comes out, they could fine you, because that is a non-compliant situation. That means that barrier failed, totally failed. You want sediment in the street. Oh, I know you don't want it on construction, but regulatory-wise, we want to have that in there. Look at those fines. That's today's world, and that can be big. I do not know, by the way, what the fine system's going to be with Hawaii with their reauthorization of their permit, but that's what EPA is today. What are barriers? If you got a rock, fine. We have a lot of granite in Colorado. If you have these fiber rolls, I look at this, I said, I hope it never rains, because that will fail. There will be failure on that sucker. Every one of these little things right in here, this happens to be straw, doesn't matter if it's straw, it could be sawdust, it could be chipped woods, it will float. I've had contractors tell me it will float here. I know it floats until they get saturated. Quit playing the game. Think about the limitation. Eddie hit it perfectly. Learn what works, learn what doesn't work. Throw the ones out that don't work. Don't do a show and tell is what I'm saying basically to all of you, because that is important. These will float. You have to put weights on them. These are another one that we've seen in Florida. Just they're tied to an inlet. Here's one that's in front of an inlet, but it's on a grade. That means the water just goes by it. Doesn't go in it. It goes by it. And for crying out loud, please do not put fabric material under a grate that's in an area drain. It does not work. It plugs up, if that's what you want. But I thought maybe we were trying to get rid of the water and the filter and the sediments. You're going to create massive flooding in there. This, by the way, was not in Hawaii. This was in Florida. The steepest slope they have in Florida is the freeways and the bridges. That's about the steepest they have over there. They have a lot of flooding. Whoopsie, hello. Okay, there's manufacturers out there have products, good products to use right. I throw this one in here because you saw Eddie said they don't use bales. Here's why. It takes a bale, a 50-pound bale, less than 6 inches of water to float. Now, you got to ask your next question. Are you going to capture trash or are you going to capture sediment? Because if you think about as we build out, the sediment is reduced every time we build homes, put a road in, put concrete walks in there. That's erosion control. So pretty soon, these inlets are just trash racks. So think about these as we go through it. This is one that was a trash rack. I understand now, Troy was telling me they have a filter fabric between these things. But basically, if this is working to capture sediment, I expect to see something like this. Do yours look like this, or do yours look like this? With any of the products you prove. So be careful. This particular one, I looked it up in there, has about that large of an opening. If you don't have that fabric material between that acts as a filter, you're not going to catch much sediment. Basically, if you look at this particular thing, particular diameters or openings in there, if you just had this flow in there, you will capture rocks, maybe some sand, but you're not capturing sediment. I want to see sediment back into here. Then I know it's working. If you don't have sediment back here and you have a construction site above you, that means it's not working. How much time we got? Okay, think about inlet inserts, because then you don't have to remove anything. The inserts themselves, little units that drop into an area drain. They have different ones. I've seen this one used here in Hawaii. They have a limitation on the volume in there, but it's a good product. We call it witch's hat. That's the name I've known it always. Then they have other ones because that's a little tiny hole and a very big gap in there. So somebody came up with something that looks like this. Do they capture any sediment? Well, I'll let you decide that one. They capture sediment. But the big thing out of this, though, after they capture sediment, somebody has to clean it out after every storm event. Ding, ding. So, what do they look like when they're installed? That's all it is. But that's a last chance. That's the last gasp on here. You should be doing erosion control always upstream, mother. Okay, the only effective to really remove sediment is to proper design set trap, and I'll be talking about that later today. This is a set trap that was in Florida. It looks like it's working good, except that it's not working good. It has flaws in it. It has flaws all over the place. Come to my session, you'll see what those flaws are, by the way. I'm not going to tell you right now. But, see those pipes? That's where water comes in. This is water leaves. You may not need to put a barrier in front of an inlet if you have a properly designed set basin. That's something that we can talk a lot about. Allow the water to go into the inlets. Don't block it, because it's going into the only treatment that removes the sediment is a basin. But whoever does these basins. See how where that pipe is? That's the inflow, that's the discharge. Water comes in, guess what? If it gets to that stage, what's going to do to the pipes? It's going to just load those pipes up with sediments because of backfill. So be careful when you do this. In summary, designers and reviewers, pointing you out because you are a key element here. Get the what works. Don't just put what's on page 84 of the manual. Get what works. Be careful though when you're talking about removing those barriers. Contractors, be leery about removing those barriers. Make sure you got somebody who gives you the right numbers to remove them. Implement erosion control. And both groups, think about what happens when those barriers are removed. Where does the water go? It goes in the Pacific Ocean. Yes, I will agree that's the best sedimentation basin in the world, all around you here, but it's not what you want to do. You're trying to keep it on the land. It's very important that we think of what happens when the barriers are removed. Thank you.